We saw last time how to get StatCrunch to make this output for us that we needed so badly. And we reminded ourselves how to find average and how to find standard deviation. Those are key, right? So now what do we do if we're just given that output? Say like on an exam. What do we do if we're just sent off with this lovely confidence interval output right here? Do we know how to read it? Okay, so this was from the fall 2011. This was a random sample of full-time JCC students to find out the number of credit hours they were taking that semester. So the confidence interval was made both StatCrunch and Minitab. And of course, I won't give you both on an exam. I'll give you one or the other. Or maybe something different. Maybe I'll find something else. So what are the degrees of freedom? So you want to look up here. In StatCrunch, you can see DF, degrees of freedom, is right there, 3119. So if you're given StatCrunch, that's easy. But if you're given Minitab, you have to find it right here because N was 3120. So you'd have to do 3120 take away 1, because remember it's N minus 1 is your degrees of freedom. So DF equals N minus 1, which is equal to 3120 minus 1, which is 3119. So one way or another, you can get it. Now, how many full-time students were sampled? Well, that's your N, right? So N was 3120. Now, if you were given Minitab, it's no problem because Minitab tells you it's 3120. If you were given StatCrunch, you'll have to think to yourself, oh, okay, if degrees of freedom is 3119, then N is equal to your DF plus 1, right? Which would be 3120. What's the confidence level here? Well, that's 95% because, right, we have 95% right here. It says it right up at the top. That's our confidence level. If you're looking at Minitab, it says it right over here above the confidence interval. CI stands for confidence interval. So right there, it tells you it's 95%. All right. Now, here's exactly what I was talking about with the table and things. So what are the degrees of freedom? Well, I couldn't give you this particular question, D, right here. I can't give that to you on a test straight up like this because you can't find this. Now, here's why. Not on a test. You could maybe find it on an online test, but not on your face-to-face tests. If you look at the table here with the t values, you think, oh, 95%, that's 0.025 for the tail, right? Because we've done this one before, but if the middle's 95%, hold on, alpha is equal to 0.05, which is the complement, right? And so alpha over 2, which is the little symbol there, is 0.025. So we want the 0.025 column, but the degrees of freedom, remember, is 3119. That's a problem because 3119 isn't in the table. So if you're on an exam, your best bet is just kind of round. Go with the degrees of freedom that's closest to what you got. So that would be 1.646. By the way, just on a side note, did you notice that the bottom row on this thing is z-scores? Yeah, that's not a myth. That's z-score. So like 95% z-score is 1.960. Handy, huh? Oh, sorry. So I meant this one was 1.962, right? Because the thousands is as close as we're going to get. So if you're going from the table, you're going to say 1.962 because that's as good as you're going to get on yourself. Hold on, I got to pick the right. There it is. So table, which is not as good, is 1.962. But if you're on a computer, then you can find it much better with Excel or with StatCrunch. So let me go back to, actually, I think I'll just stay here. No, I guess I'll make it, I got to make it its own. What's this part? Yeah, so this will be 9.2 example 5, I think is when we're on. Sample 6, what do I know? See, example 6. Okay, so this is just a repeat of what we've done before, but that's all right. So we want that critical value. So we want, remember, alpha was equal to 0.05. So alpha over 2 is equal to 0.025. So if you want to do this with Excel, you just go equals t inverse, or sorry, t dot inverse. And then the probability is 0.975. If you will, it's 1 minus that value, 0.025, comma, our degrees of freedom was 3119. Okay. All right. Now, remember, why did I do the 975? Well, that's because the area in the left tail. So alpha over 2 is the area in the right tail. So the area in the left tail is 1 minus that, which is 0.975. Okay. Now StatCrunch actually is probably easier. So let me go to StatCrunch, and you go to Stat, Calculators, T. You tell it you want 3119 as its degrees of freedom. And then you tell it you want 0.025 over here, and you want it right-tailed. Compute. Oops. 0.025. There we go. Compute. See it? 1.9607. I'll take the handy-dandy snapshot. 9.2 example 6. Export. Go back here to my results. Copy and paste back into Excel for my technology assignment. There it is. So you can see that StatCrunch also tells us that it's really 1.9607246, which is not quite what we would have gotten from the table. The table's close. The table says it's, if you look at the table, it's 1.962, which is not quite the same, right? So one way or another, you got to find this. Oh, I almost forgot. The old school Excel, the harder Excel to use, the one that's just plain T inverse. To do that, you do T inverse 0.05, comma 3119. Because remember, that one does two tails, like it makes you multiply the one tail. So equals T inverse 0.05, comma 3119. There you go. So if you're stuck with the old Excel, that's how to do it. You don't have to bother with that if you're in new Excel. You can just do this one right here. That's fine. All right, so we've got the value from the computer, which is more accurate. It says it's 1.9607. All right, now what was the average number of credit hours? That's the mean, which you can see it right there. It's 12.9, 12.9, sample mean. So 12.9. What was the standard deviation? Okay, well, they gave it to you right here on this one, 3.1. You better hope I don't ask that question for StatCrunch, because I don't, it's not in here. You could calculate it if you wanted to, because notice you're given standard error right there. Remember that standard error, here, hold on. Standard error is equal to S over the square root of n, which we know is S over the square root of, what was it, 3120. And we know that according to that StatCrunch output right here, it's 0.055. So 0.0554989. And you could use a calculator, find what the square root of 3120 is, and multiply both sides by that. And you could find S that way. So it would be a harder question to do if you were just given StatCrunch, but you could still do it. So even with just a basic calculator. All right, now what was the confidence interval itself? That would be right here, 12.79 to 13.08. Let me put some highlights in that. There we go. Now you can see it more clearly. So those are the confidence intervals. Both of them give us that information. So that's nice and easy. Now what's the margin of error? Well, you were given the confidence interval and you were given the sample mean. Remember, these are the lower edge, the upper edge, and then the sample mean's the middle. So to find the error, you take the upper edge. Here, I'll do it right here. So you take the upper limit minus the sample mean, the point estimate, right, which is equal to 13.099, oops, yes, I know, 13.009 minus 12.9, which is 0.109. You could also have done it by taking the mean, here, hold on. You could take the sample mean minus the lower limit. That would also work. So you could take 12.9, take away whatever that lower limit was, 12.79, and that would also work. Okay, but one way or another, you're going to get 0.109 to be the answer. There we go. That looks better. So one way or another, you've got your final result. You've got the margin of error. Let's move on to the last objective, which is sample size. So just like in section 9.1, we need a way to gauge how many people we need to call, how many, samples we need to take, how much blood we need to draw, how much beer we need to take out of the brewery for the sake of William Gossett. Right? So this is the formula for that. It's n equals z alpha over 2 times s over the error squared. Right? Where n is rounded up to the nearest whole number. Suppose we want to estimate the losses for the pickpocket crimes that we came up with before. How large a sample is required if we want our estimate to be within $50 of the actual population mean with 95% confidence. So you write down the formula, n equals that thing. Okay, now what about all these values? So we know s because s was given to us in the problem. I'll have to go back here to this one. All right, so s wasn't given, but we calculated it already. We used Excel, that's why I had to do it. So we used Excel to calculate that. And actually, we're just going to throw in this calculation in here in Excel for the sake of it. So we want to find n, so it's going to be equal to parentheses. Now we're going to need a z-score, which is what? Let me go back. It was 95% confidence. So again, with 95% confidence, that means alpha is 0.05. So that means alpha over 2 is 0.025. And I feel a bit like a broken record. And this is not the t-score. This is actually a z-score. You don't have to worry about degrees of freedom or anything like that. So you can look at your bottom row of your t-table. So for z, if you want a quick reference, you can use the bottom row of the t-table. Or you could use it norm dot inverse in Excel, or you could use StatCrunch or whatever. We've done it a million times. But the table's kind of nice because it's quick and it's easy. You've got it on your note sheet. All right, see this right here? This is the 0.025 column. Drop to the bottom. Right there, your z-score. The downside, of course, to the table is it only gives you a few of these. But, luckily 95% is in there because it's the most frequently used. So 1.96. So that's how I knew right here in the formula that z was 1.96. Okay, so I'm going to do that. Equals 1.96 times s, which is this 262. So I'm going to use that as a cell reference. I'm going to divide it by the error that they're allowing. Now, they said within $50. I want to be able to estimate this to within $50. So I divide it by 50, and then I'm going to square it. So caret 2, enter. And then we round up no matter what. Always round up, because you can't get 0.667 of a pickpocket. It's either they pickpocketed or they didn't. So we must round up to 106. Now, you really didn't need Excel to do this. I was just using Excel to be a glorified calculator here. You could just as easily do it with a calculator. But for the sake of your technology assignment, throw it in there and save that page. All right. So this page we kind of used it at pickpockets. So I guess we should just call it pickpocket because we used it for a couple things. We used it to find the average, find the standard deviation. We used it to make confidence interval. We had this bit in here about the critical values, which wasn't necessary, but you can throw it in there. And then this part right here with the n calculation. All right. Now, how would this change if we raised our confidence level? If you want to be more certain, you're going to need to go get a larger sample, right? If you're not allowing your standard deviation to change and all that stuff, if you're saying, hey, I want to be more confident, I just want to be more confident, but I still want to be within $50, well, then go get more pickpockets, right? Go get more data and you can be more confident. All right. What would happen if to my result, if I lower my margin of error, right? So if you're lowering your margin of error, that means that you're shrinking the size of your interval, right? You're making it so your interval is smaller from side to side. Well, if you do that, you're basically increasing your accuracy. You're saying, hey, I know that it's between not, the two values we had before of $405 to $621. It's a huge range. So I'm saying shrink that. Say it's between like $450 and $575. If you're going to do that, if you're going to shrink it, hey, I'm like 95% sure it's between $500 and $550 or something like that. If you want to get that precise about it, you can, but you're going to need to get a much larger sample, right? Right. So let me type that up. There we go. And we're done with this section.